Hello, future engineers, and welcome to another quick tutorial on how to use the rotation translation motion constraint inside of Inventor. So in this, we're going to have a pulley right here that rotates, and as it rotates, we are going to have this weight either go up or down. So let's get into how we do this. First and foremost, I have my pulley constrained in a very similar way to how I have my gears constrained over here. So I am again using one of these peg holders right here to constrain the axis of it to my back plate, which allows it to rotate freely, as well as there is a mate constraint that keeps it nice and connected right over here. So there we go. Cool. Ooh. So now what we are going to do is we are going to make sure that we have our weight in place, or whatever it is we're moving. I designed this nice little weight just for the demo. You don't have to do anything like that, though you can if you want to. There are other parts that you can use inside of the Vex library. So for this, I have it constrained where there is a flush constraint between this outside face and this outside face, so that they are a certain distance apart from each other. And then I have it constrained along this back wall, so it always moves up and down, up and down. The one constraint that I don't have is where it stops, where its resting point is, and that's where we're going to start today, because we're going to give it a resting point. So what I mean by that is I'm going to throw a mate constraint between this face, and the top face of my base, and the bottom face of my weight. So let's throw that in. I'm going to go right there and right there. So now they're constrained together, but I want to give this a certain limit. So if you open up under your constraint, you can give a maximum and minimum limit. So we're going to give this a minimum limit of 0. So right now it's stuck at 0. And then a maximum limit, we're going to try, we'll just do 7 inches right now, and then we're going to hit apply, and we'll see how far that actually moves it. So when I move this up, oh, it definitely moves too far. So let's change that. So that's my mate constraint over here. I'm gonna edit that. And let's change that maximum to something more reasonable. 5. We'll click OK. All right, so that gets us right about to where this would actually stop inside of this. So we are going to now use that constraint that we just created as our motion. It can now move up and down freely, back and forth right there. Cool. So now we want, as this one rotates, this constraint to change, that limit to change. So what we're going to do, I'm going to move this slightly up so I can still see the bottom of it. And I'm going to give a constraint again, go into my motion constraint, and this time I'm going to choose my rotation translation. So over here, we want our reverse, because we want this to turn our reverse direction and then this to go up. So we're gonna go over here. We're gonna choose first what is rotating. You have to choose what is rotating first. So this is what's rotating. And then what distance is changing? The distance of the bottom to the base plate. So I'm gonna click OK here. And then I'm going to hit apply. Cool. So now, you can see as this moves up, this rotates, goes back and forth, back and forth. Cool. Now this is rotating much faster than how we want this to actually rotate. We want it to move up at the rate of the circumference. So it's kind of tricky on this one because the circumference is actually interior right here. It is the lowest point of that, which is a little bit hard to measure, and I don't think that it'll actually... Yeah, it just gives us our area of that face. So let's see if it'll give us a circle close to it. Well, that's giving us our distance. We'll try that measure again. Cool. So we got a radius of 0.25. So cool, we can actually calculate that distance now. So I'm gonna go over to that rotation, I'm gonna hit edit. We're gonna assume that 0.25 is about the radius of this. So if you remember our nice little nursery rhyme for our distance right here, what we want to have change every single time that there is a rotation, we are going to add the circumference, which is twinkle twinkle little star. Circumference is 2 pi r. So we have 2 times pi, which is 3.14, times r, which is 0.25. So now I can click OK. And now this will rotate at the same rate as this moves up. So perfect, that is now simulated. So I hope that helped you out. That's a quick tutorial on the rotation translation constraint inside of Inventor. Please reach out if you have any questions. I'll talk to you later. Bye.